These numbers are a little trickier and aren't going to work out as nicely. That said, the first question is a little easier than what we're usually asked to do in this section, where we're trying to find variances. When we're just asked to calculate the range, all that means is we take the biggest number minus the smallest number. This is the biggest number I see, this is the smallest number I see, so I do 31.8 minus 9.0. If I put that in my calculator, it should give me an answer of 22.8. So the range of this distribution of stump samples is 22.8. When I'm now asked to calculate the sample variance and standard deviation, I need to go through all these steps. So the first thing I'm going to do is calculate x bar, or the mean. So I'm going to add together 15.2 plus 31.8 plus 9.0 plus 21.1 plus 22.4 plus 11.7, and divide it by the total number of data points, which is 6. So I'm going to get out my calculator. Just a side note, I use one of these big fancy calculators. If you have one, by all means, it will help you with this class. That said, if you don't have any calculator to use with the class, my recommendation is that you buy a TI-30X. They're about 12 bucks, 10 bucks on Amazon, depending if you catch them on sale. And basically, that's the calculator that has everything you need for this class and will get you through. We will have one section on the binomial distribution where you need to be able to do factorials and NCRs. That's definitely there on the TI-30X. If you're not sure if it's on the calculator you have, when we get to that section, give me an email. Here, when I'm going to do the sample variance and standard deviation, I have to start by putting in 15.2 plus 31.8 plus 9.0 plus 21.1 plus 22.4 plus 11.7. When I add all that together, I get 111.2, which is then going to be divided by 6. When I do divide it by 6, I get 18.53 repeating. As my mean, I'm going to call it 18.53. I now need to take each of these individual data points, subtract 18.53, and square the result. I'm going to do it for all 6 data points. It's going to give me some long numbers. Because it says I'm going to go to 4 decimal places in my final calculation, I'm going to go to 4 decimal places as I go along. I will warn you, sometimes Cengage is picky about how you round it as you went. Normally they don't want you to round to the very end, so if your answers are off by just a little bit, it might be a good idea to send them as ask your teacher to me. If it's a rounding error, I'll tell you it's just a rounding error. Continuing on, I need to do 9.0 minus 18.53, square the result. Then I need to do 21.1 minus 18.53, square the result. Then I need to do 22.4 minus 18.53 squared. And finally, I need to do 11.7 minus 18.53 squared. So I want to make sure that my calculator is doing the heavy work here. When I put in 15.2 minus 18.53 and I square the result, I get 11.0889. When I do the same thing, except now for 31.8, I get 176.0929. When I do it for 9.0, I get 90.8209. When I do it for 21.1, I get 6.6049. When I do it for 22.4, I get 14.9769. And finally, when I do it for 11.7, my answer is 46.6489. I now have 6 values for the squared distances from each individual data point to the mean. When I add these all together to get a total, I'll have the top of my formula. So I'm going to add together 11.0889 plus 176.0929 plus 90.8209 plus 6.6049 plus 14.9769 plus 46.6489. When I add all those together, I get a total of 346.2334. Again, that's the top of my equation. My last step to get variance, s squared, is to take that 346.2334, divide it by n minus 1, in this case 6 minus 1, which means I'm really dividing by 5. When I divide by 5, I get 69.24668. It says to round to 4 decimal places. This would be 4, so we'd be dropping the 8. Since the 8 is 5 or larger, we round up and get a final answer of 69.2467. If I then take the square root of that answer, S equals the root of 69.2467. For that, I get 8.32145, which I'm going to make 1.5. This is my standard deviation. This is my variance, and I previously found the range. Last part of the question just asked me to take the range and divide it by the standard deviation. If I take 22.8, divide it by 8.3215, my final answer is 2.74.